In this video lesson, we will be simplifying complex fractions. A complex fraction is nothing more than a rational expression in a fractional form. So we'll be using the previous knowledge that we have about dividing with a fraction bar. So here the first thing we want to do is rewrite 5x cubed divided by 7y squared. We're going to change our fraction bar into our division symbol. And then, as previously discussed and learned with division of rational expressions, we're going to multiply by the reciprocal. So here I'm going to multiply by the reciprocal of the second fraction. To simplify this now, I'd like to rearrange the coefficients and the variables in order, starting with the coefficients. So I'm going to rearrange or place the 5. The y to the 4th power has a 1, but I don't need to place that there. I'll place x cubed next, and then y to the 4th. So rearrange the variables together so that it will make the reducing of this fraction a lot easier. Now I'm going to rearrange my denominator by placing the coefficients together, 7 and 10, and again rearrange the variables so that now simplifying will be a lot easier. Again, we're going to try and look to see what can I do in my numerator and denominator, find a common factor so that I can reduce the coefficients. So numerator to denominator, I can divide by 5. What I'm left with, I like to write this now so that I don't forget or lose track. We can now divide our variables by using our rules of exponents. So this becomes x cubed divided by x to the 6th, which means I subtract my exponents. So I have x to the negative 3. What do I know about negative exponents? They can be replaced in my denominator as a positive exponent, which I will do in my next step. Lastly, we'll divide y to the 4th divided by y squared by subtracting exponents again, and I get y squared. Remember what I said just a couple of seconds ago? We want to rename the negative exponent. So we'll rename the negative exponent as a positive exponent in its denominator. So this will become 1 over 14 y squared and x cubed. That's the simplified form of the original example. In my next example, okay, we're going to divide rational expressions again using the fraction bar. So here we'll rewrite it as x minus 4 divided by x squared minus 9 divided by, again, and taking the fraction bar and rewriting it using division. What we know about division of fractions, we'll multiply by the reciprocal again. So multiply and flip the second fraction over. Now we'll utilize our factoring techniques in this example. That's your AC method, GCF methods of factoring. The numerator is already in its simplest form. We don't have anything to factor there. The denominator, we do have an AC form of factoring, so I will factor that into x plus 3 and x minus 3. Numerator of the second fraction is a GCF method, so I will factor out a 4, and I'm left with x plus 2. And then in my denominator, there's my AC method again. That will factor into x minus 4 times x plus 2. Again, I like to rewrite my numerator and my denominator as one big fraction, just to kind of make it a little bit easier in order for me to be able to reduce all of these factors. So now I look to my numerator and denominator to see what the common factors are. Common factor is x minus 4. There's a common factor with x plus 2. And there is no other common factors that we have. So our final ratio or rational expression would be 4 over x plus 3 times x minus 3. I hope this video lesson helped you.